The ocean. The ocean floor or seabed can be divided into two major regions, the shallow ocean floor and the deep ocean floor. The shallow ocean floor includes the continental shelf, continental slope, and continental rise. The deep ocean floor includes the mid-ocean ridges, deep-sea trenches, abyssal plains, and isolated underwater mountains or seamounts. Shallow ocean floor. The ocean floor slopes down from the edges of the continents, or continental margin, to the deep ocean basin. Most continents are surrounded by a shallow extension into the oceans called the continental shelf. At the edge of a continental shelf, the ocean floor falls away steeply, forming a continental slope. The continental slope connects the continental shelf with the oceanic crust. Part of the continents, crust, and lithosphere. Deep ocean floor. Most of the oceans cover the deep ocean floor, the thinnest part of the oceanic crust. Part of the oceanic crust and lithosphere. The mid-ocean ridge is perhaps the most prominent feature of the ocean floor. Giant, volcanic mountain range. A rift valley runs down the center of the mid-ocean ridge. Deep in it, magma from the mantle rises and cools down to form a new oceanic lithosphere. Mid-ocean ridges mark the boundaries of the tectonic plates that are moving away from each other, causing sea floor spreading. Trenches are the deepest ocean features. They are long, deep, narrow valleys that form from old parts of the oceanic lithosphere. The abyssal plains are between mid-ocean ridges and deep-sea trenches. Flat and featureless, covered in a thick layer of marine sediments. Sometimes there are small individual underwater mountains called seamounts. Most of them are extinct volcanoes. How do we explore the ocean with the use of sonar sound navigation and ranging? A sonar system sends sound signals down to the ocean floor, listens for the signal to bounce off the floor and return, and then calculates and records the amount of time it takes for the signal to make the round trip. The two main ocean environments. Scientists divide oceans into two major zones. The benthic zone, which contains rocky floor and sediment that covers it. The pelagic zone, which is the open waters above the floor. Conditions in both zones vary by their depth. Zones of life in the oceans. Scientists subdivide ocean environments into zones by their location to the shore and depth. The pelagic zone is usually subdivided into epipelagic, also known as euphotic or photic zone, receives enough sunlight to support photosynthesis. Mesopelagic, also known as dysphotic zone, receives very little sunlight. Bathypelagic, also known as aphotic zone, in which there is no light penetration. The seafloor is considered a separate zone, known as benthic zone near the coast, and the abyssal zone in the deep ocean. The Earth's three atmospheres. First atmosphere, formed approximately 4.5 billion years ago along with the planet. Mostly made out of hydrogen and water vapor, small amounts of nitrogen and methane. A collision between Earth and a massive asteroid blew off huge chunks of the planet, along with the atmosphere. Second atmosphere, between 4.5 and 2.4 billion years ago, volcanic activity released huge volumes of steam and gas. Large amounts of water vapor, carbon dioxide, and nitrogen, oxygen didn't enter the atmosphere. Eventually it entered the environment. Third atmosphere, about 2.4 billion years ago, excess oxygen accumulated by photosynthetic organisms. Mostly nitrogen and oxygen with small amounts of argon. It's Earth's current atmosphere. Most abundant gas in the atmosphere is nitrogen, which occupies about 78% of the volume of air. Oxygen occupies only about 21% of the volume of air. Pressure is the amount of force per unit of surface area. The gravitational force on a column of gas above a surface increases density of the gas near the surface. Density is the amount of mass of a substance divided by its volume. With less pressure there are fewer gases, in a given volume of air. Heating Earth's atmosphere. The Sun is the primary source of energy that heats Earth's atmosphere. Thermal energy is transferred in three ways. Radiation, transfer of energy by electromagnetic waves, form of energy released by moving charged particles. Conduction, transfer of thermal energy by collisions between particles of matter. Occurs only when substances are in contact with each other. Convection, transfer of thermal energy by a flowing substance, like water or air. Circulatory movement. Uneven heating of Earth's surface. There are several reasons as to why Earth's surface is heated unevenly. Curvature of Earth's surface, most important reason as to why the equator is warm and the poles are cold. The equator receives more sunlight than the poles. Distribution of land and water. Land absorbs and releases thermal energy much more rapidly than water does. Water absorbs it more slowly but holds onto it longer. Differences in ground cover. Because land absorbs it more quickly, surface layers can be extremely hot. Atmospheric transparency. The clouds may deflect radiation back into space. Forming wind. Caused by differences in air pressure. Atmospheric circulation is driven by solar radiation. Uneven distribution of thermal energy in the atmosphere. The Coriolis effect. Earth's rotation also affects the direction of air movement. Some describe the Coriolis effect as the deflection of a moving object's straight path by Earth's rotation. Layers of the atmosphere. The troposphere is the layer closest to Earth's surface that humans live in and interact with every day. It extends from the planet's surface to 12 kilometers high in the atmosphere. The stratosphere is the second layer of the atmosphere. It extends from the top of the troposphere to 48 kilometers above the surface of the planet. The ozone layer is found in the stratosphere. The mesosphere is the third layer of the atmosphere. It ranges from the top of the stratosphere to about 86 kilometers above the planet's surface. The thermosphere extends from the top of the mesosphere to about 600 kilometers above the planet's surface. The exosphere is the final layer in the atmosphere. It extends from the thermosphere to 190,000 kilometers above the planet's surface. The exosphere gradually blends into space.